All right, good night. We're looking at 2009 CAPE, and we're going through corrections of this paper. So we begin. Again, this question, you have a rubber weight, and this rubber weight has a weight. The weight acts vertically down, obviously. So this is your weight acting down here, W. You have your tension acting here, and they're telling us that a wind is holding this ball in equilibrium. Now, once they use the word equilibrium, we know that the upward forces must be equal to the downward forces. We know the forces to the right must be equal to the forces to the left. We know that. That's what the word equilibrium brings. And therefore, this is the principle upon which we need to answer this question. So we have this tension story going on here. And they want us to write, see which equation is correct. But the first thing we can do is write equations for equilibrium here. And in order for us to do that, we should really look at the components. So this is angle theta here. And this tension is acting like this. So the tension has a vertical component. Let's call it vertical component T1. And the tension also has a horizontal component. And let's call that horizontal component T2. Now we have the upward and downward force. The upward and downward forces must be equal. We have the force to the right. It must also be equal to the force to the left. That's what equilibrium is. What is T1? We can resolve forces to find what T1 is. And we know that T1, if the angle theta would be here. You can transfer this angle theta into the Z thing. The angle theta is sitting right here as well. And we can see that T1 is on the adjacent side. So immediately we know, since it's on the adjacent side, T1 must be related to the cos of theta. In fact, T1 is equal to T cos theta. And T2, it's on the opposite side, as I taught you. And if T2 is on the opposite side, then T2 would be equal to T sine theta. And if we wanted to go along this path here, we can say for equilibrium in the horizontal plane, T sine theta must be equal to the force to the right. The force to the left must be equal to the force to the left, which is H. And therefore, we can get that T is equal to H over sine theta. We're good. Now, this is not one of the options. We go in the other direction now. In the other direction, we look at the vertical forces, and we can see that W, which is the downward force, must be equal to T cos theta. And therefore, if we make T the subject, T, because all of them, T is the subject, T is equal to W over cos of theta. And from here, we see this there. And therefore, the answer has to be C. This is not there. I mean, there's only one correct answer. Obviously, this is wrong because T cannot be equal to W because they're acting in different directions. Obviously, T cannot be equal to H for the same reason. So the only possible answer is C. That makes sense. I'll just keep moving. Once you have questions or to engage me in discussion, please engage in discussion. All right, question 2. Now, question 2 is an error-based question again, and we are asked to find the percentage error here. We are asked to find the percentage error, and we know that the percentage error in this equation, we can write the percentage error form of this equation. And the percentage error form of this equation would be delta rho over rho by 100 must be equal to delta M over M by 100 plus, because it's L cubed, it becomes 3 delta L over L by 100. Second. Sorry about that. I had a quick run off there. And it was recording fine. So we have the equation here, and this is what we want to find. All right? Delta M is this. This is delta M. And so on. So again, to be quick, I can show you the solution. Same equation. When we substitute the numbers and run the math, we get that it is 14%. Any questions on this? Going once, twice, going forward. All right. Next question, which is of the following gives the dimensions? Now, this is a question on dimensions, gives the dimensions of the universal gravitational constant. We know that F, the gravitational force F, we know is equal to mg, is equal to G m over r squared. And we need to find this. We know the dimensions of everything else. So I propose we just use this part of the equation. The m's will cancel out if we're using this part of the equation. And we can express big G as, in terms of the rest, big G would be equal to gr squared over m. Right? When you transpose, the r squared goes on top, the m comes in the denominator. And we know G, the unit of G is ms to the minus 2. We know that R would be in meters squared. And we know that M, the mass, would be in kilograms. Again, just replacing the units of each of the things. And we just combine these together. And when we combine them together, we get the meters, and the meter squared becomes meter cubed. The kilogram from the denominator comes up in the numerator, but it has to be expressed kg to the minus 1. And the meters, the s to the minus 2 remains s to the minus 2. And that is right here, E. Kilogram to the minus 1, see it? Meter to the 3, see it? S to the minus 2, s to the minus 2. In this one, we want to find the number of moles in 0.060 kilogram. But we know that because the molar because it's carbon 12, it means 1 mole is contained in 12 grams. Grams is the operative term, so we should convert this to grams. This 0.06 kilograms is 60 grams. .06 kilograms is 60 grams. And we know to get the number of moles N is equal to the mass divided by the molar mass. We know that. The number of moles is the mass, which is 60, divided by the molar mass, which is 12, and it gives us the number of moles to be 5, and the answer is B. This one is interesting, where we want to express milligrams and in kilograms. So like Y is 9 kilogram. Y, I can write the value for Y. 9 kilograms is 9 by 10 to the 3 grams. That's 9 kilograms, that's Y. Y is equal to some constant times X. There's a relationship between Y and X. Y is equal to some constant. If we want to find this constant, it's the constant that differentiates the answer. But X, they're telling us X is 3 milligrams. Milli is 10 to the minus 3. So this is 3 by 10 to the minus 3. And therefore, to find K, we just transpose K is equal to 9 by 10 to the 3 divided by 3 by 10 to the minus 3. And from here, when you do your math, you will get 3 by 10 to the 6. And therefore, this is the only one that has that constant, and therefore C becomes the answer. Questions? Nothing? Good evening,
No,
Alex.
sir.
So can you go back to that question so I can screenshot it, please?
You know, I'll share the whole file with you, right? Or you want to screenshot it? No,
Oh,
that's,
okay. Never mind.
I'll send the entire thing to you at the end of the
Okay.
class, right? Now, this one is an interesting question. Let's describe it. You're releasing this mass of plasticine. Its initial velocity is 0. And this plasticine is obviously going to accelerate. When the plasticine just reaches the top, where the top of this trolley arrives, when it reaches the top, the plasticine, they're telling us, has a velocity of v. The plasticine is accelerating from the initial velocity of 0 to v. And when that happens, this trolley is being fired with the same final velocity, with the same velocity, but this is a constant velocity coming along. Now, the same time it takes for this plasticine to fall, this plasticine falls through a height of h. That's the height it falls. This trolley, on the other hand, is moving from some point here to here. And if this height is h, I don't know what this is. I'll call this s. This is some unknown distance that this trolley was sent from. So again, simultaneously at t is equal to 0, the plasticine is released. And at the same time that the plasticine is released, the trolley takes off from this position, a distance s away. And when this trolley just reaches here, that plasticine strikes it with a velocity v. So the plasticine falls through a height h importantly in time t. The plasticine falls through a height h in time t. And at the same time, the trolley moves a distance s in time t. They're doing this motion in the same amount of time. One is a constant velocity, the other one is accelerating. Do we understand what the question has presented? They want us to find s. But do we understand? This trolley is starting with a constant velocity and moving with that constant velocity. This plasticine is starting at rest and accelerating to reach that same constant velocity. Now, again, I've written down a solution to the answer to the question. I was working on this afternoon. And this is what I have written down, where I'm saying the trolley moves with a speed v. And for that time t, the trolley, its motion s, the distance it travels s, is equal to its velocity v by that time. We don't care about this time, we just know it's the same time as here. So the trolley moves, the equation for the motion of the trolley, s is equal to vt. That's how far the trolley moves, because the trolley is moving with constant velocity. Anybody has a problem with this equation? Everybody understands this little concept here. It's two parts.
Yes, sir.
All right, Andreas is good with it. Everybody's okay with that? This is comfortable.
Yes, sir.
Yes, Chalia, you okay?
Sir, can you, where did we get the 2h from?
Where we got the?
The 2h from?
Which
Wait,
two?
hold on, no, never mind. Okay.
I'm
Never
going to
mind.
answer here just now. I'm just starting up here. Are you okay with this, Chalia?
Yeah.
All right, this is saying that distance is equal to velocity by time. If there's no acceleration, s is equal to ut plus a half at squared. We okay with that, right? Now,
Yes.
the second part is where this plasticine is falling. All right. Now, the mass takes a time t to fall through a height h. Now, this is the critical point. You see this here? If it's starting with a velocity of 0, and it's reaching a velocity v, then we can work out the average velocity. The average velocity is initial plus final over 2. It's like this. You have a graph like this, right? You have a graph like this, right? And this is your v, and this is 0, and this is t. If I ask you what is the average velocity here, you ought to know that the average velocity, you ought to know that the average velocity is a velocity exactly midway here. Exactly midway here. That's your average velocity. This is the average velocity, v over 2. Because the average velocity is that constant velocity that encloses the same area. We know that average velocity v bar is equal to u plus v over 2. All right? So this is the average velocity. And we know another equation that displacement s is average velocity by time. So for this plasticine, for the plasticine that falls, s, the distance it travels, which we're calling it h, is equal to the average velocity multiplied by time. So this equation is for the plasticine. H is equal to v over 2 by t. And we already have another equation that s is equal to vt. So we can see by substituting for vt, we can see that s would be equal to 2h. I mean, there's a common sense way of doing it. This is a mathematical way of doing it. Everybody clear on this? So this trolley, it makes sense. If it's traveling at speed v, it has to travel twice the distance. If this one is traveling at speed v over 2, it has to travel twice the distance in the same time as this. This makes sense. We clear?
Yes, sir.
Yes, sir.
Anybody want discussion on this? Everybody clear on this? I mean, we here not just to say for people who understand the concept to say, yes, we're good, but we here to for people who having trouble to somehow message me in the group chat, message me in WhatsApp, or say, listen, I don't get that. And I will break it down further or have a discussion with you.
So you could just re-explain how you get S is equal to VT.
How I got S is equal to VT. All right, so this trolley is moving. Let's call the distance a trolley. They tell us that the plasticine is falling through a height h, so we can't use h. S is the distance that the trolley is moving. We do not know what S is. That's what we want to find at the end of the process. Now, if we know that the velocity is v, right? If we know the velocity is v, and if we know this thing is traveling for a time t, and we want to find, so how far did it travel in that time t? How far did it travel in that time t, which is what the question is asking. How far? Then S is equal to, many equations for S. S is equal to ut plus a half at squared is the equation we would use. And since u, in this case, the speed is constant, the speed is called v. And since the acceleration is 0, then S would be equal to vt. S is equal to the velocity of this multiplied by the time. You see, I want time. Why do I want time? Because time is the thing that they both share, you see. This is moving from here to here in time t. This is falling from there to there in time t. So time is the thing I want in both equations, because that is what will cause me to eliminate the t and find one S in terms of the other.
Yeah, thanks.
Okay. Uh-huh. All right. I'm sorry. I don't know what's going on there. All right. Come on. Move. Nudge them along. All right, next one. A man throws a ball with a velocity v through the air and so on towards his friend. Which of the following graph represents the vertical component? The vertical component we want. The horizontal component is parabolic motion. We know the horizontal component will be constant, but we want the vertical component. And if somebody is pelting a ball, throwing it from a friend 60 meters away, clearly you cannot pelt it. I mean, if you're pelting it, it will be some motion like this, not so. Parabolic motion, right? Which is what I already drew. This is the path of the ball. This distance is 60 meters. So when the ball is projected, the ball is really projected in this direction, but it has a vertical component that is up. The vertical component starts at a maximum value. It does not start here. It does not start there. It does not start there. So immediately we know. Immediately we know that it starts with maximum velocity. We know it reaches at the maximum height, the vertical velocity becomes 0. We know that when it reaches back to be caught by his friend, the velocity is downwards, therefore it's going to be negative. We know these 3 points. We also know, that's the first part. So we have these 3 points. We also know that vertically, the acceleration is constant. And it is also down. What does it mean by constant acceleration? Constant acceleration for a velocity time graph means what? Constant slope. Means the gradient must be constant. This is the only one. On all those levels, this has to be your correct answer. Where? I'll reveal all the other stuff. I don't want to jump to the thing. Number 8, a spring is permanently connected between 2 blocks on a frictionless surface and so on. The mass of the blocks are 2 and 5 and so on. It can move freely. Freely means no friction. The spring is compressed. If the spring is compressed, if you compress this spring, clearly, according to Newton's third law, the compressed spring will be pushing to the right on this, and it'll be pushing to the left on this. And according to Newton's third law, if a body A exerts a force on body B must be exerting what? An equal and opposite force. So these 2 forces that the compressed spring would exert on the 5 and the 2 kilogram object would be equal and opposite. And therefore, that being the basis of the solution, this is the remainder of the solution. From Newton's third law, I'm saying F1 must be equal to F2, because when the spring is compressed, it'll be pushing off on both of them. And for the heavier block, they've given us some data. For the heavier block, they've given us the acceleration. Therefore, F1, which we know is equal to MA, will be 5 by the acceleration that they gave. We're good. And therefore, the force F1 will be 50 Newton, meaning that the force F2 must also be 50 and produce an acceleration of 25. We good?
Yes, sir.
Yes, sir.
All right, the following statements refer to inelastic collision. What does inelastic mean? That's the first thing. Inelastic means that KE is not conserved Not conserved means the initial kinetic energy is different from the final kinetic energy. They're different. While momentum is conserved. that the initial momentum is equal to the final momentum. So that's what an inelastic collision is. Kinetic energy is not conserved, momentum is conserved. So now to the question, the total momentum is not conserved. Clearly that's rubbish. The total amount of kinetic energy is not conserved. We just said that, not conserved. The total amount of momentum is conserved. So the answer is 2 and 3. All right? And therefore, I'll reveal. All right? The answer is D. Number 10. Interesting question. Two satellites, S1 and S2, are orbiting around a planet. So they're both orbiting around the same planet of radius r. S1 moves just above the surface, so therefore the radius of S1's orbit would be r. And S2 has an orbital radius of 4r, meaning from the center of the planet to S2 would be 4r. I've already rendered this in a diagram to make our lives a little bit easier. Right? I'll go in tighter to show you. What they're telling us from the question is S1 is orbiting with a radius r. S2 is orbiting with a radius of 4r. They're both orbiting the same planet of mass m. Now we know for stable and steady orbit that the gravitational force must be exactly equal to the centripetal force. That's the first premise of this solution, that the gravitational force must be equal to the centripetal force. If the gravitational force is not equal to the centripetal force, the orbit would decay, or the object will lose its orbit. Do you understand this? If the gravitational force I had explained before, if the gravitational force on this is bigger than the required centripetal force, this object will spiral towards the planet. It will crash. It will not be a stable orbit. So this is the premise for all stable orbits, that the centripetal force is exactly equal to the required gravitational force. Now mv squared over r is equal to gmm over r squared. The masses cancel out. We can eliminate one of the r's and we end up with a simplified equation that for all stable orbits, equation is true for all stable orbits, v squared is equal to gm over the radius of that orbit. This is a fact. This is true whether the orbit is small, whether the orbit is big. Once it's a stable orbit, this equation is derived and true. And therefore, because this question is based on the orbital speed, that's why I wanted the equation in this form. I could have written this equation with the omega. Again, I could have written this equation. This is the centripetal force is mr omega squared. But this question does not come with omega. It talks about speed, so I want this version of the equation. So that's what I need. I'm going to use that. So therefore, for S1, Vs1, look at the equation. Vs1 is going to be equal to Gm over capital R. See it? The root of, this is square root, right? Vs1 is going to be the root of Gm over capital R. For S2, Vs2 would be Gm, the root of Gm over 4R. And because Vs2 is in the denominators here, I flip it and I just do a little bit of mathematical juggling. And I get that ratio of orbital speed over S1 to S2 is 2. I know some of you have some challenges with math. Do you follow this, or do you need me to break it down further?
No, sir, I just need to copy it down, sir.
Everybody understand this?
Yes, sir. Well done.
Yes, sir.
All right. So I'm going to move on. Next. Again, I was trying to write up some solutions to make our process a little smoother, but I didn't get enough time to do all, but we'll see how it goes. Which of the statements below best describes the motion of a geostationary satellite? What is a geostationary satellite? A geostationary satellite we know has many properties. Again, we're revising. A geostationary satellite has a period of 24 hours. A geostationary satellite orbits above the equator. A geostationary satellite orbits from west to east. It moves around the Earth from west to east. And what the most important one is, a geostationary satellite remains at a fixed point. A geostationary satellite remains at a fixed point above the Earth. It remains at a fixed point above the Earth.
So,
As the Earth rotates, it remains in the same position above the Earth. All right? Yes?
for the third point, right?
Yeah.
Why does it orbit above the equator?
Because if it orbits above any point other than the equator, it will not be geostationary. We had explained that if we have the Earth and we have the equator, and we are in Trinidad right here, I'm sure you remember this diagram. From the time I start drawing it, you will remember the diagram. If we're in Trinidad here, right, and we have a satellite that is parked up right above our heads, just directly above our homes. And this is at 6 a.m., 6 o'clock in the morning, right? At 6 a.m. in the morning, it's directly above our heads. 12 hours later, where's Trinidad going to be? Trinidad is going to be on the exact opposite side, not so. That's where Trinidad is going to be at 6 p.m. You agree? Where would this satellite be at 6 p.m.?
The same spot?
All right. It'll be in the same spot, like park up right here still?
No.
Maybe in the same spot.
It will be with Trinidad.
So you think it's going to be, again, several options. Do you think it's going to be here in position A? Is it going to be here? Directly above our heads? We're talking about this satellite has a period of 24 hours. It's orbiting the Earth, so it has a period of 24 hours. Would it be here?
Yeah. That geostationary satellite, right? Means if
let's back up a little bit. I never said this was geostationary.
Oh, okay.
I'm trying to explain a point. And I'm using this analogy, and you'll see what I'm talking about in a little while. This is not a geostationary satellite right now. Okay? So I'm saying if it starts here, off, this is the equator. If it's not above the equator, and 6 a.m. is above our house, would it be above our house? Its period is 24 hours. The period is 24 hours, just like the Earth. In 12 hours' time, would it be above our house? Or would it be here? And those of you who were in class in a week would know that it will be here. Why? Because the satellite orbits what point? It orbits the center of the Earth, not so. Joel, you good?
Yeah.
All right? It has a period of 24 hours at 6 a.m. If the satellite is above our house, at 6 p.m., it's not going to be above our house. It would not be in the same position. Therefore, a satellite that is here, that is off the equator, would not be geostationary. But if I had a satellite sitting right above the equator, you seeing it now? I'm just changing.
Yeah.
If I have a satellite sitting directly on the equator at 6 a.m., where's it going to be at 6 p.m.? It's going to be in the same relative position from our house. It's going to be a little bit south of us on both occasions, not so by the same angle as well. And therefore, the satellite must be above the equator if it is to be geostationary. Apart from having a period of 24 hours, it must be above the equator. Anytime it's not, like here, not on the equatorial plane, it will not be geostationary. It will shift its position during the course of the day. It would not have this most important property, which is remain at the same fixed point relative, to the point on the Earth or your home or whatever it is. That's totally clear now.
Yep.
How many of y'all remember this diagram from lessons? Anybody remember this diagram from lessons?
Yes, sir.
Yes, sir. We did the same diagram. That's how I normally would introduce the idea, to make sure that you know that it must be above the equator. It cannot be any other point, because since the object is orbiting the center of the Earth, it will be here. And therefore the angle with our home would be different. At 6 a.m. it's 90 degrees above our heads. At 6 p.m. it's a totally different angle in a different position. So that's not geostationary. We good?
Yes, sir.
All right. Let's continue going along. All right, so this one I wrote nothing. A plank shown is in equilibrium and acted upon by the forces. I didn't read this one even. Which of the statement is true? P, is this a plus sign or, yeah, it looks like a plus sign. T plus P is equal to W. You agree with that? Absolutely, yes. Upward forces must be equal to downward forces.
So what was the answer for the one previously where it was known?
Sorry, say again?
What was the answer for the one previously with the geostationary satellite?
Geostationary. Sorry. Which is best that describe motion? The motion is same velocity of the Earth. That's rubbish, right? Can't be the same velocity of the Earth, because it's so far out that it must be moving faster than any point on the Earth's surface. Again, V is equal to R omega. They have the same omega, but because the R is different, because the radius is different, the V would be different. The geographical location changes as the Earth rotates. That we know is rubbish, because by the very definition it's off. The acceleration is 0. How could it be moving in a circle and have 0 acceleration? Rubbish. So we get the picture. The answer is D. The angular velocity. The angular velocity is equal. Angular velocity is omega. Omega is equal to 2 pi over T. And we know that both the satellite and the Earth must have the same period right here. They must have the same period. So the angular velocity would be equal. All right, back here. P into X plus Y. P into X plus Y. If I took moments about here, all right, then P into X plus Y will be clockwise moments, and W by Y will be anti-clockwise. And since we're talking about equilibrium, this is true. Px is equal to Ty. Px is equal to Ty. That is also true. And therefore the answer is D. This is true. This one is true because if I took moments about here, then the clockwise moment, which is Px, would be equal to the anti-clockwise moments, which is Ty. You can take moments about any point in the system. All right. Anybody want clarification? Yeah?
You can explain how the P into X plus Y is equal to WY. I don't understand how that one is correct.
Sure. If I took moments about here,
right,
what will be the clockwise moments? The clockwise moments will be P multiplied by this distance.
Y, yeah.
All right? So the clockwise moments, clockwise would be equal to P into X plus Y.
Y, yeah.
Again, we're taking moments about here, right?
Yeah.
And the anti-clockwise motion, this one, anti-clockwise moments would be equal to W multiplied by Y.
Yeah. Okay.
And equilibrium means that the clockwise must be equal to the anti-clockwise. So P into X plus Y must be equal to W by Y.
Thank you, sir.
We're good. All right. And the other one for anybody who unsure, the other one is when I took moments about here. When you take moments about here, this is still clockwise, but this clockwise moments, the clockwise moments for the green fulcrum is equal to X multiplied by P. And the anti-clockwise moments, that is this one here, the anti-clockwise moments now, the anti-clockwise will be T multiplied by Y. All right? And if for equilibrium, Px must be equal to Ty. Px must be equal to Ty. We're good.
So can I ask, how is it that the just now the clockwise is P and you add in X plus Y, but T is only Y. But
Oh, why you say the clockwise is P, dog?
so no, as P by X plus Y, meaning the with P you length, but with W the anti-clockwise.
All right, so
Oh, okay, I understand.
you good?
Yes, sir.
It's force by distance. This is the whole distance.
That makes up T with W.
Yeah? Okay, good. Next one. A rock is thrown vertically upwards from the ground, neglecting air resistance. This graph shows the relation kinetic energy of the rock with height. Now, if it's thrown vertically upwards from the ground, if you're pelting a stone up, it must start with maximum kinetic energy. All right? And we have, second. Yeah. So we know it starts with maximum kinetic energy. All right? So we know this can't be right. One time we eliminate this vertically upwards, neglecting air resistance. The best graph shows the relationship between kinetic energy of the rock and the height h. We know that, so we have three options here. And we have to decide on one of these. Let me see. Second, I have to write to figure it to get my proof. Oh, that's easy. All right. Sorry, I thought I was seeing something more challenging. That's real basic. What do we know about this ball? This rock that is thrown vertically starts up with a certain amount of maximum kinetic energy. And as it climbs, the kinetic energy decreases, but as the kinetic energy decreases, the potential energy increases. In fact, the mechanical energy is constant. The mechanical energy of this ball is constant. What is mechanical energy? Mechanical energy is the kinetic energy plus the potential energy. Once it leaves your hand, it is getting no more energy. Whatever kinetic energy it loses, that's how much potential energy it has. Everybody understands that. So I can write an equation for this mechanical energy. I'm calling this mechanical energy ET. The total energy is not changing. ET is constant. ET is equal to the kinetic energy plus the potential energy. And we want a relationship between kinetic energy and height. So we can transpose this equation and give us that E, which is the kinetic energy, is equal to ET is equal to ET minus mgh. So if you look at the relationship between E, the kinetic energy, and h, the height, you can see it has a negative slope, not so, negative mg. But the important thing you can see is that it's a straight line. It's a straight line function. It's of the form y is equal to c minus mx, or mx plus c. And therefore, this is a straight line, and therefore the answer has to be D. Everybody understands this?
Yes, sir. Excuse me, sir. How do we know it starts at maximum?
Sorry?
How do we know it starts at maximum kinetic energy?
Okay, so if I throw a stone, if a stone leaves my hand at 5 meters per second, it's traveling upwards. Does it travel faster than 5, or does it travel slower than 5 as it climbs?
Faster.
Really? So if that was physics, then SpaceX wouldn't have any need, because then I could jump off the ground at 5 meters per second and then zoom up faster and faster, and don't need no rocket. You get the point?
Yes, sir.
So when an object leaves your hand, it leaves your hand at the fastest. Once it leaves your hand, once it doesn't have its own propulsion, it leaves your hand with the biggest speed. And thereafter, it slows down because it is converting that energy you've imparted to it. It's converting some of that energy you gave to it to potential energy. So the kinetic energy must be decreasing as it climbs.
Okay, sir.
All right?
Thank you very much.
I like the question. These are the questions I want to answer, because these are the questions that people don't want to ask. Right? So I appreciate the questions. Thank you. We clear so far? So
Yes,
we give it this much energy. This is the kind of discussion I want in these. I don't want to be just spouting solutions and you're just absorbing what you think you absorb. Debate with me. Ask me questions. I love the debate. It's not about the debating, it's about clarifying concepts and getting down to those fine nitty-gritty. All right. This one. A van has a mass M. And the reason I gave you the year is because I wanted you to look at some of these questions. A van has, sorry, let me just make the point. The next one of these years I'll be doing, for those of you who find it, I'm moving too fast. I know some of you may find I'm moving too fast, but it is your fault of your own. Blame yourself, because if I'm moving too fast, it means you didn't try to go through this paper to try to get some of the questions that are difficult, isolated, so you could think about them. All right? This session, I can't just put this up and wait for you to read it. That's not an efficient use of my time. I'm supposed to go to a wake tonight. One of my friends died, and tomorrow's the funerals, and so I have to. I'm going to the wake tonight after I'm finished with this class. But you know, I'm just like you. I'm putting things aside because you're important, and I want you to make it as if I'm important and my time is important to help you. So the next, if you didn't do it, the next session, you'll find I'm going too fast still. The next session, when I propose a year, you sit down with that year and spend at least an hour or two trying to find what you don't understand. And when you come and you ask me these questions, I love it. Then I will break it down for you and you will understand it completely. All right, enough talk. Moving along. A van has a mass M. The van's engine has maximum power P. The least time the van will take to accelerate from rest is. Now, we know that E, kinetic energy, is equal to a half mv squared. We also know that E is equal to PT. I can replace this E because I know the power. I don't know the energy. I know the power. And the power, the E would be P over, in fact, I wrote this up already. Sorry, I think. Let me not write on top. When I reveal all, it tends to be one on top of the other, and I don't want that to happen. So I think I wrote the solution to this already, which is right there. PT, that's the E I said. PT is equal to a half mv squared. And therefore T, the time it takes, T, would be mv squared over 2p. Again, I'm starting with the equation. I should write the other one, that E is equal to a half mv squared, and that P is equal to E over T. And I'm replacing the E, and I'm solving. We good?
Yes, sir.
Hey, Nikolai disappeared. What's going on? People getting booted out or something? Or internet dropping off? Faria, I see you had to join back.
Somebody in the rating room, so.
Yeah. No, I saw people in the class and then I see them joining again. What's up?
That's some internet.
Oh, the internet messing around, I understand. No problem. I just want to know the reason for it. All right, so this one is, again, I wrote up the solution to this one. This one is a repeat question that comes all the time. All right, a student of weight 500 Newton is planning a trip to Blue Mountain from her starting point. This will involve an increase in altitude of 1800. Okay, so if there's an increase in altitude, what is happening to her? She's gaining potential energy. How much potential energy? MGH. Which is, MG is, this is weight. Weight is mg. So the amount of potential energy is going to gain is 500 multiplied by 1800. No problem. That's the first sentence. She buys a high calorie energy bar that releases 1000 joule of energy when digested. Assuming that the body only uses 10% of that energy, how many bars does she need to eat? Well, this here, 10% of the energy she's getting from the food, the energy she's getting is equal to 1000 kilojoule, right? 1000 kilojoule by n, the number of bars she eats. That's how much energy she will get. If she eats n bars, the amount of energy she's going to get is 100,000 by n. No problem there. But energy, useful energy. The energy she can use to do this, the useful energy, is only 10%. 10% written mathematically is 0.10 by 100,000 by n. So this is the useful energy. This is the energy that she can use to climb the mountain. Not all of this, the useful energy. And that is why I wrote the equation in this form, that MGH is equal to 0.1 by n, which is the number of bars she's eating, which you don't know, by 100,000. And here, since we already got MGH, we can solve for n to get 9. We're good?
Yes, sir.
Yes, sir.
Moving.
Wait.
Wait. Screenshot in 2, 1, go on.
Miss it.
What boy? I'm going back. You have an Apple thing. You're supposed to get a screenshot already. Go ahead.
Yes, I get.
You get? All right, number 16. All right, so again, I wrote up the solution here already. A mass hanging from a spring with a force constant K oscillates vertically. Now, once we know mass on a spring, we're supposed to know there's an equation in the period T. Once we know this, period T is equal to 2 pi root m over K. That's an equation we are supposed to know. So don't ask me where it comes from. I can derive it, but its derivation is no longer needed. It's in your notes for a spring. For anybody feel an earthquake?
No, sir.
All right, probably mine.
No, sir.
All right. So maximum velocity. Maximum velocity. We know that maximum velocity for simple harmonic motion, V, is equal to omega by the amplitude A. Again, this is another equation we're supposed to know. That the maximum velocity of a body performing simple harmonic motion is omega by the amplitude, omega A. And that's where I started, that maximum velocity is equal to omega A. That T is equal to that omega, this omega is 2 pi on T. So when I do 2 pi on T, when I transpose and bring this T in the denominator, the m and k, the root m over k flips when they go on the other side of the equation. Cross multiply again, right? K over m. And this 2 pi on t is your omega. Omega is equal to root of k over m. So since we know v is equal to omega a, I can replace this omega with this, and we end up with this, meaning the answer is that. Got it? Moving, I go on.
Wait, so can you
Can I? Yes.
how I understand how you substituted the 2 pi on t is equal to k on m. Okay, oh wait, okay, never mind. I understand now.
Sure, great. I don't want you all to be die wondering. These sessions are about, if you can't get all 45 questions, that's fine. Whatever we get, we understand thoroughly. That's the point. Next one. The displacement of a particle undergoing simple harmonic motion, that's the equation. What's the frequency? Again, the general equation is x is equal to x0 sine omega t. That's a general equation, what they're talking here about. Omega is, we know, is 2 pi f. The other version of omega is 2 pi f. 2 pi over t, 2 pi f, same thing. So when you look at this term here, we are seeing that omega t is equal to 0.4 pi t. So omega, which is equal to 2 pi f, is equal to 0.4 pi. And therefore, we can solve for f. And the answer for number 17 is A. We good?
Yes, sir.
Next one. System made up of a light helical spring in which a mass is attached and forced to oscillate at a different frequency in air. The response is shown. If this experiment was done in an evacuated chamber simply means less friction. And what happens when you have less friction? Happens when you have less friction? The amplitude of the response is going to be greater. The less friction does not change up the natural frequency. It just allows the thing to swing through larger amplitude, less friction. So you see this amplitude only goes up to here. This amplitude in the same range, it goes up much more. All right, sharper and higher. Number 19. Stationary waves are produced by superimposing progressive waves of frequency 500 Hertz. Successive nodes. When they say successive nodes are separated by 2 meters, we know that in a standing wave,
It's separated by lambda over 2.
That's right. In a standing wave, lambda is from here to here. That's lambda in a wave. But in a standing wave pattern, it's an envelope of vibration. And therefore, successive nodes would be node and node. What is the difference between successive nodes? It's half of the wavelength. So they're telling us the difference between successive nodes is 2 meters. Therefore, it tells us lambda must be double that. If this is 2, lambda must be equal to 4. And we have F. We have lambda. We solve for V. Got it?
So you could run over how you got lambda again.
Lambda, sure. In a standing wave, right? This is, let's say, a 1 wave. Let's go in tighter. This here is a wave. One complete cycle goes from here to here. You okay with that?
Yes, sir.
And one complete cycle represents a distance of lambda. In a standing wave, the standing wave is an envelope where you have an opposite wave stacked on to make this point a point of zero vibration, a node, and another point of zero vibration, another node. And if you look at how far these 2 points are in relation to what lambda is, you realize that this is 1/2 of that. So if they're telling us the distance between, this is what they gave us. They gave us the distance between successive nodes is 2 meters. It's another way of telling us that lambda is 4 meters. Talk to me, okay with that?
Yes, sir.
Sure, because I could go and pull up the handout and go further, but once you got it, you're fine, we're fine. Number 20. The diagram below shows an instantaneous position of transverse waves traveling from left to right along the string. So the wave is traveling like this, right? Which of the following correctly describes the subsequent motion of any of the points RS on the string? Right? Now, when we did this, I told you, and I can do it here a lot easier in the software. Let me just try it. Right. All right, you all remember this? If we want to find how a particle is moving, what do? We take the entire wave pattern and you shift it slightly in the direction of the velocity. So this entire wave pattern is shifting to the right. Everybody seeing that, right? The entire wave pattern is shifting to the right. No problem. Go to another layer. Now, that tells us that the particle, I'll just go in tighter. R is here, and a little bit later, this is where R is. So R, therefore, must be moving down. Change color. In order for R to go from here to here, R must be moving down. And at the same time, S must be moving up. You have another point on the system? No, just that. R must be moving down. At that instant in time, R is moving down and S is moving up. Neither of them stationary. So R must be, the answer is B. We good? Yes?
So,
Yep.
Yes, sir.
Right. Next question. Two sources of waves X and Y generate, two sources of water waves X and Y generate waves which are out of phase by 180 degrees. What does it mean by out of phase by 180 degrees? It means that
destructive interference.
destructive interference, right? So in other words, it's like having a 5 mixing with a -3. And if you have 5 mixing with 3 in the opposite direction because it's out of phase, we're going to get 2. Make sense? And therefore the answer is A. Amplitude would be it would not cancel out completely. It wouldn't add because that's when they're in phase. They would add to be 5 plus 3 equals 8. They're 180 degrees out of phase, so we're dealing with destructive interference. This one is by definition, the intensity of a sound I is proportional to the amplitude squared. You have to know that as a fact. A standing wave is set up on a stretch string XY as shown in the diagram below. Which of the following statements is correct? Oscillations of point P and Q are out of phase with each other. Is that correct? Absolutely yes. Particle X arrives at point, people crazy. Oscillations of point X and Q. X does not move. X does not oscillate, it's a node. Oscillations of point Q and S are exactly in phase with each other. No. We know that any point in all points in one internodal, this is a node and that's another node. This is a node and that's another node. All points here will be displaced together. They will all be in phase. But all points in the adjacent internodal region, they will be oscillating or moving in the opposite direction. They will be in phase with each other, but there'll be a 180-degree phase difference between these two. And in this internodal region, all of these points will be in phase with this and out of phase with that. Okay? And
so adjacent internodal regions, right?
yeah.
Is where amplitude direction is opposite.
The oscillation is opposite, not amplitude. The amplitude is the maximum displacement. Maximum displacement doesn't care about up or down. Maximum. The scalar, right?
Yeah, because I was struggling to understand that before.
But you've never seen this before?
Well, I see any book. They say that.
I can teach you from a book, man. You know that. Come on. Come on. Don't make me seem like some random lessons teacher. I'm a different level. Nobody on my level.
Different from Ramda.
Nobody on my level. Well, they might like them more than me, but they're not on my level. They still learn from me. Trust me.
Let them know too.
If I like them, well, it's not a problem because I know I'm not as good looking as some of them. But just a second. I have to find
Nobody on your level.
It's a video I showed you. What? Unit 1. Right. 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 Tell me now. Tell me I didn't see this.
I did too.
You did?
Yeah.
They're different. Totally different. You see how they're moving? One is moving as in this. These are. Let's pause it here. This is a node here. This is a node here, and that's a node. This one is vibrating up. This one is vibrating down. Their displacement, they have opposite directions, not opposite amplitudes, opposite direction of displacement. When one moves up, the other one moves down. We good? You can see it? When
Yes, sir.
Check it. See it?
Yes, sir.
That's
Yes, sir.
180 degrees out of phase. All right, we clear? Figure 24 refers to the following diagram, which shows a stationary wave on a string at one instant in time. That's a stationary wave. Where's the stationary? Where on the stationary does the node exist? A node is a point where the displacement is zero. The displacement is not zero once. The displacement at a node is always zero. All right? But an antinode is where the displacement is maximum. But the maximum displacement isn't always maximum. This maximum displacement varies from zero, positive, slightly positive, more positive, negative, and so on. So this is a node for sure. This is another node for sure. This is another node for sure, because the displacement is zero and will always be zero. But in between two nodes, what do you have? Antinodes. In between nodes, exactly in between nodes, you have these things called antinodes. And therefore, where on the stationary wave does the antinode exist? P and R. We good? This one is an interesting question. But once you know this equation, it's not really so interesting. It's pretty basic. They're telling us a liquid X floats on a container on top of another liquid Y, whose velocity of light is Vx, sorry, Vy. Sorry, somebody outside. Right. Floats on top of another liquid Y. Blah, blah, blah. Okay, basically, let's see what we're saying. Material Y, angle theta Y, velocity Vy. Material X, angle, whatever it is, whether it be here or there, angle is theta X, velocity in this medium is Vx, no problem. X and Y different. The important part of it is this. The pair of which pair of statements is true if the wavelength, see this here? This is the critical part. What does it mean by the wavelength decreases? How does the decrease in wavelength, how is it related to angle? How does wavelength relate to velocity? And that's why we're supposed to know this equation. Vy over Vx is equal to lambda y over lambda x is equal to sine of theta y over sine of theta x. Everybody knows this equation? Or do you want me to show you where it comes from?
Yes, please.
We know it, right?
Yes, sir. I want to see where it comes from.
Where it comes from, right? We know that the refractive index n from medium y to medium x, what defines the refractive, what's the definition of refractive index? The definition of refractive index is the speed of the wave in medium y. Again, that comes first, that's going tighter. And again, trouble to write there. The refractive index from y to x is the speed in y over the speed in x. No problems there, right? That's by definition.
Yeah.
And we know that velocity Vy is equal to f by lambda y, not so? V is equal to f lambda. Fy, let's call it Fy for the sake of argument. And similarly for x is Fx lambda x. But what do we know about frequency? We know that frequency is constant. We know that frequency of a wave does not change as the wave moves from one medium to another. This is the O-level objective. You're supposed to know that. And therefore, this cancels out with that. We good? And therefore, the definition that the refractive index from y to x is equal to Vy over Vx can be converted to lambda y over lambda x. We good so far?
Yes, sir.
Now, beyond that, there was a law called Snell's law. That's without doing the long proof. Snell's law, which tells us that the refractive index from y to x is equal to sine theta y over sine theta x. That's called Snell's law. And therefore, I can bring all these three items together. This, which we already see is related to that, and we can then stick this in to make it one big equation. We good?
Yes, sir, thanks.
No problem. Now, once we know that, once we know this identity, and they're telling us that the wavelength decreases in going from y to x, they're telling us that lambda y is greater than lambda x. The wavelength decreases. It's going from y to x and the wavelength decreases. And if lambda y, look at it here, look at the math. If lambda y is greater than lambda x, then guess what about v? Vy must also be greater than vx, not so. Right? And therefore this statement is true. And this statement is true. This is wrong. These two are wrong. Vy is greater than vx, vy is greater than vx. Now, looking at the same equation again, if lambda y is greater than lambda x, lambda y over lambda x is sine theta y over sine theta x. Mustn't theta y also be bigger than theta x? Lambda y is bigger than lambda x. Theta y must be greater than theta x. We good so far?
Yes, sir.
And therefore, theta y must be greater than theta x, and therefore the answer will be E. Next. In a Young's two-slit experiment, light of wavelength 500 nanometers produces fringes of 2 millimeters apart. So 2 millimeters apart, that's what? 2 millimeters apart. What's that? We know the equation for the double slit. We spoke about this last day. Today's Thursday, it was yesterday. That y is equal to lambda d over a. So the wavelength, that's your lambda. The fringes is 2 millimeters apart. That's your y, 2 by 10 to the minus 3. And they're giving us, if the light wavelength of 250 nanometers is used and the slit separation is doubled, all right, what's going to happen? That's pretty basic. 26, the answer is C. All right, you want to run the math? Let's try to run the math. I just want to give my brain a little break. I kind of feel a little, I need some water. Just give me a second. I'm going to grab some water. Try the question in the meantime. I don't have to go far for water. Touched. Should I pause the video? All right, so you all getting through this? I'm getting B.
Same here, sir. Same here, sir.
I'm getting B as the answer, not C. Anybody seeing any mistakes that I made?
No, sir, I get B
Sir,
too.
I get B as well, sir.
All right, well, B is the answer. Let me make sure I didn't put this as a wrong answer somewhere. I want to check something. This is 2009, number 26. Just give me a second, right? I just need to fix this as I'm here on this now. No, I have the answers B. I just wrote some stupidness here. Okay, fine. So the answer is B. Oh, sorry. Talking to myself and teaching myself. The rest of you all understand what I did?
Yes, sir.
The one thing that is constant, is D. Somebody said something, sorry. Chile, are you okay with it?
I'm a little lost.
All right, sure. And so the equation we have is y is equal to lambda du over A. Now, this is how we treat with this question, right? Of these four quantities, two of them definitely changing. They're telling us lambda is changing. In this equation, they're telling us that the wavelength is going from this to this, so the wavelength is changing. They're also telling us that the slit separation, which is A, is also changing. You with me? And they want us to get some information about Y. In other words, the thing that is remaining constant is D. Tilly, you okay with that, right?
Yes, sir.
So what we do in a context like that is we know that D for the 500 nanometers is going to be the same as the D for the 250 nanometers. So how we do such a question is we would write the equation in terms of D, which is what I have here, and I substitute the information for the 500 nanometers. What information do we have for the 500 nanometers? We have the wavelength, 500 nanometers. I didn't have to put the N because it'll cancel out. With me? I have the fringe separation, which is 2 millimeters. I do have to put the mm because I know my answer is going to come out in mm, so I'm going to put mm. Fine. We good? And I'm going to call the separation for the 500 nanometers, I'm calling it X. We good so far?
Yes, sir.
That's for the 500. For the 250, we know lambda is 250. They're telling us that the slit separation is doubled. So if this one is called X, this would be 2X. Again, we're running the same equation. Y, A over lambda because they're both equal to the same D. So 2X here. We good? And Y is what they want us to find. How far apart are the fringes when we're using 250 and doubling the separation? So this must be equal to that. And after that, the rest is simple. Just cancel out and solve for Y. Talk to me, Talia.
I understand. Thank you so much.
That went kind of wonkily. I didn't hear half of what you said. But if you say you understand, we'd have to debate it.
You hear me?
Sorry?
Yeah. Thank you.
Welcome.
I was following along.
All right.
Thank you.
You're welcome. 27. X-rays differ from microwaves in that they have a shorter wavelength. That's all. That's basic. All right? Everything else is true. Number 28, I already wrote up a solution. We know that decibel, and I spent some time on this concept, that decibel is not just to talk about hearing. That is the intensity level in relation to the minimum intensity. Decibel, the term decibel is used for many, many things. And one of the things it is used for is amplification. If you have an amplifier, amplifiers increase the intensity of a signal by decibels. If you're looking at transmitting a signal from one place to another, as the signal is being transmitted, the signal becomes weaker. That weakening of a signal in transmission is called attenuation. Attenuation. Attenuation or decrease is also measured in decibel. So, and finally, decibel is used to compare two sounds. There are many applications of decibel. And in lessons, we had spent some time looking at other uses of decibels. There's some questions, drill questions that I'd gone through on one occasion. On one occasion only I did it because it's not something that they normally ask. So, in this question now, what is the ratio of the intensity of what is the ratio of the intensity of two sounds if one is 8 decibel louder than the other? What are they talking about? The decibel scale is expressed by the equation 10 log I1 over I2. Again, you will see this equation. This is the decibel scale. 10 log I1 over I2. So if we are saying that one is 8 decibel louder, the louder one will be in the numerator and the softer one will be in the denominator, and the number on the left-hand side will be 8. 8 is equal to 10 log I1 over I2. I1 is the louder, I2 is the softer. And therefore, we can just solve this equation. When we solve this equation, we do the anti-log operation, which is, I wrote the detail of the anti-log operation here. 10 to the 0.8 is equal to I1 over I2. And therefore, 10 to the 0.8 is 6.3, and the answer is B. Question me now. Questions, I'm just sneaking across. Okay, fine. Accommodation in the human eye refers to the, is it the dilation of the pupil? That's rubbish.
E.
Adjustment of the lens to focus object. Or, here we go. B. Changing the shape of the eye? No, you don't change the shape of the eye, you change the shape of the lens. Use the lens to correct defects in vision? No. All right, so we understand that straight from our basic knowledge. We did this question just recently, but the solution is here. Again, there's another solution that people tout. Somebody just messaged me. I'm Joel.
So you can go to that question after the paper, please.
I'll think about it. All right. Number 30. All right, tell me if you're okay with the solution. This is the solution I tout. I know they do a 1 over this and a 1 over that, and they come with a number. And if somebody would spend time to explain that to you, that's fine. But I teach this concept, the concept of the power of the eye using a particular approach, and I'm going to keep that approach constant. So I start here. The other juggling of numbers, it's shorter. It's just one line and it's done. I know it. I'm not trying. I'm just trying to keep my teaching consistent with the theory that I've taught you. So we know that the eye has a near point. The standard eye has a near point of 25 cm. Standard eye. And a near point of 25 cm means that the power of the eye has a power of 54 diopters. If somebody's near point is further than that, it means that their eye is operating at something less than 54 diopters. And therefore, if you want to make the eye 54 diopters, you have to increase the power to use a convex lens to bring back this near point here. In this case, in this question, they're telling us that the person can see the near point is 30 centimeters away. And the power of that person's eye at 30 centimeters, I did the calculation already, the power at 30 centimeters is not 54, it's 53 1/3. And therefore, if I want to correct that defect, I need to get them up to 54. What do I need to get them up to 54? I need to give them an extra power of 2/3 diopters. And we know that the power of a lens, I should write that equation, the power of a lens, the power of the corrective lens, we need to put a lens of this power. The power of a corrective lens is 1/f. Therefore, the focal length of the lens to fix the eye, it must be 1/p. Right? And therefore, 1/p, if p is equal to 2/3, 1/p, which is f, must be 3/2, which is 1.5 or 150 centimeters. And that is the way I would teach it. That's the way I've taught it. And this juggling of numbers to get the answer is not something that I've taught you, and therefore I would not use that. The explanation of that is a lot longer than this. And I am not interested in doing the two numbers and subtracting. It's a subtraction that you're doing right here. It's a subtraction that you're doing between this and that. All right, to fix it. I'm not going there. Not going there. This is pretty straightforward as it is. Done. Which of the following types of thermometers has the widest temperature range? Absolutely, yes. The length of a liquid column in a mercury thermometer at ice point is 15. So that's, we know the equation that theta is equal to x theta minus x0 over x100 minus x0 by 100. That equation is the defining equation for the centigrade scale. We know that, right? Well, we ought to know that, but I trust you do. This here, at the ice point, this is my x0. The steam point, this is my x100. And this would be my x theta. And we just have to substitute these and solve. What do you get for the answer? Anybody work this out? Number 32. I don't remember the answer.
87.8.
Thank you. Answer B. When you run the math, that's what you get. That's how straightforward it is. Come back. Okay. An immersion heater rated at 150 watt is fitted into a large block of ice at 0. The specific latent diffusion is that. How long does it take to melt 10 grams of ice? Come on. PT, which is EH, is equal to M LF. So therefore T would be equal to M, which is, this is in per kilogram, so I'll convert this 10 gram to 0.01 kilogram. Multiply by LF, which is 3 by 10 to the 5. Over the power, which is 150. Power is 150. So we just solve that. With 33, I have C. It looks reasonable. 34. Which of the following statements is or are true? Whilst a substance is melting, the temperature remains constant. Absolutely yes. The triple point of a substance has a constant value. Absolutely yes. The boiling point of a liquid does not depend. Absolute rubbish. Does depend. So the answer is B, 1 and 2. The boiling point of a liquid does depend on the pressure of the surroundings. Everybody knows that, right? If you were to try to boil water in a pressure cooker, water boils at 120 to 150 degrees in a pressure cooker. That's why a pressure cooker takes a shorter time to cook food, because you're supplying, you're heating it to a higher temperature. If the pot is open, you could only heat it up to about 100 degrees at sea level. In a pressure cooker, you can cook it at 140, 150 degrees. So you need less time to do the same amount, put in the same amount of energy into the food. On top of a mountain, if you try to boil water on top of mountain, water boils at 80 degrees on top of a mountain. So that the reason for that is the pressure, right? I mean, I don't know if you all do chemistry, but when I did chemistry about 100 years ago, I was taught that a liquid boils. I don't know if you ever heard this. A liquid boils when the saturated vapor pressure equals atmospheric.
Yes, sir.
So the boiling point depends on atmospheric pressure. All right. Water falls from 500 meters. What is the rise in temperature at the bottom? If all the energy is converted to thermal energy. So we have mgh is equal to mc delta theta. I know many people get stumped by this question because they ask, what the mass of water? It doesn't matter what the mass is, it cancels out. So therefore, delta theta, the change in temperature, is equal to gh over c. We know g is 9.81 or thereabouts by h, which is 500. And the specific capacity of water is 4,200. What do we get? Anybody?
C. I mean D, sorry. 1.17.
D? Okay. 1.17 Kelvin or 1.1 degrees Celsius, you know, is the same thing. Because when you talk about delta theta, whether they put it in degrees Celsius or Kelvin, changes in temperature is always the same. Again, you can show that very easily. All right. Please. An insulated composite metal rod consists of 30 centimeters of metal with a conductivity of 300 watts, and 30 centimeters of metal being 200. An insulated rod of metal A of length L conducts heat at the same rate as the composite bar when the length L is equal to. All right. The answer has to be D, without doing any math. It's about equivalent conductors, right? What is the equation for equivalent conductors?
KB on
Over the
LB.
thickness is equal to K2 over the second thickness.
Right. K1 over L1 is equal to K2 over L2. So I want to replace this by an equivalent conductor. All right. We know that this is 200 over 30 over 0.3. I'll put it in meters one time. Over 0.3 is equal to K2. K2 will be the material like A, which has a thermal conductivity of 300. All right. Over L2. And we can solve here for L2. And L2 is going to be equal to 300 by 0.3 over 200. And that works out to be 0.45. We good? That's L2. That's the L2. If we were to replace B by a material that is just like A, we would use a piece of material that is not 30, it is 45 centimeters. And we have the same piece of A sitting here, which is 30. And therefore the length of the entire thing that we would need to have the same, to be equivalent for theta 1 and theta 2 would be 75. Clear?
Yes, sir.
Anybody troubled by this? This is the equation for equivalent conductors, meaning that I want to replace B by a length L2, an unknown length L2 of a material similar to A. So I know what K1, I know what the thermal conductivity of B is 200. I know the length of B is 0.3 meters. I know the material of A has a thermal conductivity of 300. So I can find L2, the equivalent length of A I have to use to replace B. And that works out to be 45 centimeters, 0.45 meters, which I added to the 30 of A to give you the total length. No problem. Number 37. A large metal cube has dimensions of that and that and that. It's heated to in the blackened. All right. P is equal to sigma A T to the 4. All right. It's just putting in numbers. You just have to find the volume, the surface area, sorry, is the surface area using. All right. So it's 1.2 meter by 1.2 meter, and there are 6 faces. You have to multiply by 6. All right? So it's sigma by...
Excuse me, that's a standard formula or something?
Of course, yeah.
Oh.
Yeah, this is the emission formula. There are 2 formulae in radiation that we have to know. Just a second. There are 2 formulae in radiation that we have to know. Module 3. Radiation. Right? It's called Stefan's law. That's the formula we just used there. It's called Stefan's law. And it says that when a body is radiating, the rate of radiation P, when a body is radiating, the rate of radiation, the rate at which it is putting out heat energy is sigma. Sigma is called Stefan's constant. It's 5.7 by 10 to the minus 8. By A is the area, the surface area of the object. So if it's a cube, you have to find the area of all of the faces, all 6 faces. See? And T to the 4, T is Kelvin temperature. So whatever temperatures we're dealing with, we have to convert it to Kelvin. All right?
Okay, sir.
Now, there's another equation that I want to just point out to you one time. And this is when we talk about net. When we're using the term net heat transfer, oh, come on. Where is it? Oh, it's right here. When we're using net, for example, if that cube is radiating heat, but it's also receiving heat, then you have to use 2 temperatures, because not only is it losing, it is also gaining. You follow? And in that case, you have to use the 2 temperatures, T1 to the power 4th minus T2, the difference here. So it's the same law, just applied twice to the body. This is the net. Whenever you see them use the word net, see this? Anytime they use the word net heat transfer, net, you have to use this form of the equation. If they talk about heat gained, not net, or heat lost, we're using the other form, this form of the equation. Got that?
Yes.
Number 38. Which graph best represents the pressure P of a gas as a function of its mass when the gas is pumped in the container, fixed volume and temperature remains constant? It's kind of obvious it's going to be C. Because if you double the number of molecules, if you double the amount of gas, then you expect twice as many collisions. All right? But more importantly, PV is equal to 1/3 Jabari, I'll answer that in a minute. We're good. And we can see that pressure is proportional to mass. Pressure is proportional to mass. So we have this relationship. All right, the question is, why is it to the power 4? Because when Stefan studied the relationship between pressure and temperature, he found that pressure was not proportional to temperature directly. He found that pressure was not proportional to temperature squared. That pressure was not proportional, power was not proportional to temperature cubed. But he found when he plotted pressure to temperature fourth, he found that there's a relationship. And that's why there's a 4 in this equation here. Because Stefan is the one who collected the data, did the analysis, and came up with this relationship, that pressure, that power is proportional to temperature to the power 4th, and not any other power of temperature. I hope that answers the question. So you just have to know this. It's not this, it's not that, it's not that, because it does not have a linear relationship. When he plotted power with temperature, he got a curve. When he plotted power with temperature squared, he got another curve. When he plotted power with temperature cubed, he got another curve. But when he plotted pressure with temperature fourth, he got a straight line. And therefore, that is the relationship that we use. (39) Which of the following statements is not one of the basic assumptions of the kinetic theory? They're elastic. They're not inelastic. Right? What is the pressure of a gas of density that and root mean squared? Okay, the equation we're supposed to know is P is equal to 1/3 rho. So all you have to do is put in numbers in here. You have density, you have RMS, and you can find P. What's the answer for this? Anybody knows the answer for this? Number 40. C. The first law of thermodynamics may be written in the form delta U is Q plus W for an isothermal. What is isothermal? Isothermal means constant temperature. Constant temperature for a gas means that delta U, the change in internal energy, is 0. Why? Because constant temperature means the internal energy is constant. Constant temperature means the internal energy is constant. Therefore, changing something that is constant is 0. And therefore, if that is so, then Q must be equal to minus W, right? Q, 0 is equal to Q plus W, and therefore Q is equal to minus W, which is D. Clear?
Yes, sir.
A material whose length L and cross-sectional area A, when a force F is applied to material, equals section E, which is the following expression equals to Young. All right, FL over A. We know that Young's modulus normally called E, is stress over strain. Stress is force per unit cross-sectional area, and strain is extension over original length. And when you move things around, you get FL over AE. This is called stress, and this is called strain. Number 43, which of the following statements about a molecular model of liquids is true? Their molecules are packed closely together. The neighboring molecules cluster near constant transfer. Yeah, that's true. The forces between molecules are very strong. That is strong. The pattern is not fixed. That is true. So it's something that has 2 and 4. The molecules, they packed. If you look at the volume of a solid and liquid, would you say that a solid and liquid has vastly differing volumes? If you look at a solid and liquid of any material, would you say that the volume is vastly different? A liquid and a gas, yes, for sure. But if you look at ice, ice shrinks by a small amount, by 1/10, some small fraction like that. So the molecules in a liquid is still closely packed. So I will accept, this is possibly an answer. This is true. All right, this is true. And this is also an acceptable answer, D. This is definitely true. This is definitely true. This, you can argue that this and that, they're equally correct. You can look at it different ways. So you can accept 2 possible answers. Sometimes I look at A and say yes, and sometimes I look at D and say yes. So I don't know what their answers are, but I can argue both of them. But I guess A might be technically more correct, because when a solid is produced, there is some expansion. So if a solid is closely packed, in the same way that a solid, the force is a different thing. So I can accept both A and D. A, I guess, might be the better answer, because this is always going to be true and this is always going to be true. Right? .44, the graph below is obtained by applying various forces after a piece of wire, right? What information is transferred is input from the graph. Force constant on material is 1000. I don't know. Force period extension. So we're seeing that 0.01 meter. Oh yeah, this is true. We are seeing that an extension of 0.01, we know force constant K is equal to force over extension. And we're seeing that the force increases by 10. And when the force increases by 10, the extension increases by 0.01. And this is 1000 Newton per meter. Right, so that's true. The ultimate tensile stress, that's the point where ultimate tensile stress is when oh, come on. This is stress. Stress is force per unit area. Stress is not expressed in Newton. If this was stress, then this value will be the ultimate, the maximum here will be the ultimate tensile stress, if this was stress. But it's not stress, it's force. So ultimate tensile stress does not exist in the thing. The strain at X is 3%. Strain is extension over original length. And the extension from here to here is 0.03. The original length I would call here, which is 1.5. What is 0.03 over 1.5? I don't know what that is. What is 0.03 over 1.5? Anybody?
0.2.
2%, sir. 2%, sir.
2%. 0.02 or 2%. So it would not be this. And the material obeyed Hooke's laws up to 30 newtons. So it obeys Hooke's laws because it has a straight line function. It's wrong. And the answer is 1 and 4, A. Any questions?
So,
yeah.
Yes, so what is ultimate tensile stress?
Ultimate tensile stress is the maximum stress that any specimen can bear before it starts to yield. So if you had a stress strain graph, if you had a graph of stress against strain, for an elastic material, a ductile material, the stress strain graph looks something like this. Right? It looks something like that, right? The ultimate tensile stress is the maxima. That here is your ultimate tensile stress. Okay?
Okay, thanks.
Yeah. Come on. The lag and then it jumps and have to move it back slowly, slowly. All right. Next one. Item 45 refers to the following diagram. How much work is done in stretching a wire from that to that? And the answer is this area here. That area. So half into 30 plus 60 multiplied by the distance between them. The distance between them is 1 by 10 to the minus 3. Which, yeah, C. Okay, we good?
So you could just go back to number 43 so I could take a screenshot.
Sure. Second. Number 43. Right. All right, so wow, we didn't do too bad. It took us 2 hours, but we did the entire paper. Let me just stop the recording.